Alright, here are the solutions to the 2018 linear and quadratic functions tests. So let's go through these problems. Okay, this first one here is just a basic perfect square expansion. So we want to expand and then simplify this situation here. So you can use the perfect square expansion rule, which is to square the first term. So that is 4x squared. And it's 2 times this term times this term, so it's 2 times 2x, which is 4x, and 4x times 3x is 12x, and then it's square the last term plus 9. So it's 4x squared plus 12x plus 9, but remember, a way to always do this one if you're unsure of the rule is just to go 2x plus 3, 2x plus 3, and then expand by multiplying the front and that one there and that one there. So you can just expand that in the normal way. Alright, on to this next one here, which not many students got correct. So what we note about this part of the expression here is that this is a DOPS situation, or a DOPS problem. And this problem here is just subtracting all of this. So what we're going to do is use the DOPS rule to expand that. And then we're going to remove all of this. Right, so DOPS will say that the middle two terms cancel out. Okay, so what we're going to do is 4x by 4x. So that's 16x squared. And 1 times 1 is negative 1. So we're going to go 16x squared, take away 1, subtract. And we're going to do the subtraction of all of the result of the expansion of this. So we're going to go 3x squared, take 5x, plus 21x, take 35. And I'm going to say that that's 16x squared, take 1, take away, and I'm just going to collect up the like terms here. 3x squared plus 16x take 35. So that's the same as 16x squared take 1 take 3x squared. So we're taking away this, we're taking away this, and we're taking away this. Subtracting the negative means that this is plus 35, and this is where most of the students came unstuck. Alright, so what happens here is we've got 16x squared take away 3x squared is 13x squared. Now we're going to take 16x and plus 34 when we collect up those like terms. So difficult problem, that one there, but nothing new from really what we've done in the past in year 10, even year 9. Okay, factorise each of the following expressions. Now remember what Mr. Tench always says is always check when you're factorising whether you can pull out a common factor first of all. And in this instance we can. Okay, so what we're going to do is yank 4 out as a common factor and say that this is x squared take 9. And what we're going to do then is treat this as a DOPS problem, which is 4x squared take 3 squared, and then we're going to run the DOPS rule on this. 4x take 3, x plus 3. Okay, the next one, what we're going to do is rewrite this in, well, I call it DOPS form, I don't know what it's officially called. 3x plus 5 all squared take 4 squared. So now we've got the difference of 2 squares. Alright, now this is the same as 3x plus 5 take 4, 3x plus 5 plus 4. Alright, now what we're going to do is simplify these, and we've got 3x plus 1, 3x plus 9. We're also going to note that this can be factorised here, so we're going to go 3x plus 1, take 3 out as a common factor, x plus 3, and then let's just shift that to that spot there because it's multiplication. We're going to go 3x plus 1, x plus 3. Alright, so for this problem here we're just noting that this is what we call a non-monic trinomial. Okay, non-monic means that the coefficient of the squared term is not 1. Alright, so this is a bit of a game changer in the way we treat the factorisation of this. So what we do is we go, what is 12 times 2? And that's 24, and that forms our target number. So what we're going to do is consider the factors of 24, that when they're either added or subtracted equal -11. Okay, so I'm just thinking here, 6 times 4, 8 threes. It's going to be 8 threes. Alright, so it's going to be -8 take away 3, and negative times a negative is a positive. Alright, so what we must do at this stage now is go 12x squared, take 8x, take 3x plus 2. Now this stage has to happen, and what we're going to use now is this grouping 2 and 2 technique to factorise the problem. So now we've got 4 as a common factor here, 4x rather, 3x take 2, take 1, 3x take 2. Alright, now we've got 3x take 2, which is coming out, and 4x take 1. Take away 1. Alright, and there's our factorised process. Now, a lot of students, what they did was, when they worked out that, they just said that the answer was x take 8, x take 3, which then, if you expand that, it's just clear that we're not going to get this as a result. Okay, look at the constant you're going to get, 8 threes at 24, okay, not positive 2. So note that when you get a non-monic situation, you have to use the grouping 2 and 2 method. Alright, this is what I call a hidden quadratic question. Okay, so what we've got here is, we can turn this into a more standard looking trinomial, one that looks like this, or like that, simply by saying, let's let y equal 2x plus 1. Alright, so now let's make this substitution. It's y squared take 5y plus 6. Alright, now we can just treat this as your standard factorised problem. So what we're going to do is consider the factors as 6, that when added or subtracted equals -5. So 6 times 1, and what's the other one? 2 times 3. Okay, and this one will be the winner here. So this time, because it's monic, we can actually go straight to the binomial products. Y take 2, y take 3. Now what we're going to do is re-substitute 2x plus 1 in. So we're going to, instead of saying y equals, or y take 2, we're going to say this is the same as 2x plus 1 take 2, and 2x plus 1 take 3. So we should be putting our equal signs in there. Alright, so now we've got 2x take 1, 2x take 2. And we're again noting that we can pull out a factor of 2 there, so we're going to stick that out the front and say that's 2x take 1, and that will be x plus 1. X take 1 rather. Okay, so yeah, again a bit of a tricky one, that one, but use the hidden quadratic technique there on that one and you'll be fine with that. Right, how many solutions, okay, does the equation have? So now what we're doing is we're attempting to solve, and when we talk about number of solutions, we're always talking about the discriminant. Okay, so what we're going to do is run the discriminant of this. There's a little bit of housekeeping that we've got to do on it first, so what we're going to say is 3x take 5x plus 3 equals 0. So we've got to have, to run the discriminant, it's got to be in ax squared plus bx plus c form, because remember the discriminant requires us to get the a, b and the c values to use it. Okay, so in this case the a value is 3, the b value is -5 and the c value is +3. Alright, let's write the discriminant. B squared take 4ac. And our b value is -5, and we're going to square -5, so -5 times -5 is 25. Take 4 times a, which is 3, times c, which is 3. Discriminant is 25. Take away 12, 12 threes are 36. The discriminant is -11. So how many solutions does it have? Well, because the discriminant is negative, it has no solutions. So I need to say that. So discriminant is less than 0, therefore no solutions. So you really do need to interpret what the meaning of the discriminant is there to grab the marks for that question. Okay, solve each of the following equations for x. So what we can do for this one there's a couple of ways of doing this one, so I'll do both ways. I'm going to pull 2 out as a common factor here. X squared take 5 equals 0. And if I divide both sides by 2, that cancels the 2 on this side, and 0 divided by 2 is 0. So I actually can just go x squared take 5 equals 0. What I can do then is either use dots to do this, or I can just say this, x squared equals 5, add 5 to both sides, square root this and square root this. The important note to make is the answer to this is plus or minus root 5. Whenever I square root something, it's going to be the plus or minus. Now if I used dots at this point to do this one, I could say this, x squared take 5 equals 0, and to turn it into a dots problem, I just square root and square the 5. In which case, if we use dots to factorize this, x squared take root 5, x plus root 5 equals 0, and then it's pretty clear that we have got two solutions, x is root 5 or x is negative root 5. Okay, so sometimes using dots can ensure that you remember the plus or minus, because students often using this technique forget the negative solution. Alright, this one here, I can see from a quick factorise it's a Monic Trinomial, but 4 is not going to make, or the factors of 4 are never going to make negative 8. So I go to my second plan, which is the quadratic formula. So I check that the trinomial is equal to 0, which it is. So now it's ready to go, and we can bang these numbers straight into the quadratic formula. B equals negative 8 and C equals 4. Okay, so the quadratic formula is x equals negative b plus or minus the square root of b squared take 4ac, the discriminant, over 2a. So let's whack in these results. So I've got negative 8, which is 8, plus or minus the square root of b squared, which is 64, take 4 times 1 times c, which is 4, all over 2a, which is 2. X equals 8 plus or minus. Now that's 64, take away 16. So that is 64, 54, 48 over 2. Now many students left it at this point, but it's implied that what you've got to do is simplify this. So what we're going to do is simplify the surd. So I'm going to say that x equals 8 plus or minus, and 48, I'm just going to do root 4 times root 12. So 2 root 12 over 2. Alright, now that means that we can cancel, or this is the same as 8 over 2 plus or minus 2 root 12 over 2, 4, and those cancel out. X equals 4 plus or minus root 12, which also simplifies to 4 plus or minus 2 root 3. Okay, so yeah, that was just a standard quadratic formula problem. Alright, sketch each of the following functions, labelling the coordinates of the axial intercepts and turning points if they exist. Alright, so this is the y equals x squared parabola moved 2 units to the right and 4 units down. So there's 2 to the right and there's 4 units down, and that's the turning point of this parabola. Okay, now what we've got to do is get the x-intercepts. The x-intercepts occur when y is 0, so 0 equals x take 2 squared take 4. We're going to add 4 to both sides. Now I'm going to square root this side, and that gives me plus or minus 2 equals x take 2. Don't need that bracket. Alright, now what I'm going to do is add 2 to both sides, so I'm either adding it to positive 2, which is x equals 4, or I'm either adding it to negative 2, in which case x is equal to 0. Okay, so one of my x-intercepts should be 0, the other one should be 4. That looks symmetrical, so that means that's a good sign. I could find out the y-intercept, but of course I'm going to find out that it's at the origin as well. So now I'm ready to sketch this parabola. Not bad. And we want to label these points to -4, 4, 0, and what's this one? The origin, 0, 0. Okay, this was a shambles, this question. A number of my class didn't detect that this was actually just a linear function. So what have we got here? We've got a y-intercept at 6. So there's the y-intercept. And the x-intercept occurs when y is 0. 0 equals 2x plus 6. -6 equals 2x. X equals -3. So the x-intercept is -3, and we just need a line that runs through those points, drawn with a ruler, and labeling those points. So that is 0, 6, and -3, 0. Alright, so I had many people drawing quadratics or parabolas for this, certainly not parabolic. Okay, determine the values of m if this has two distinct solutions. So what we've got is a parameter question, and it's telling us about the number of solutions. So generally when this is the case, we have a discriminant problem. So what we're going to do is run the discriminant on this. Remember, it needs to be in ax squared plus bx plus c form, of which that is. So let's write down the a value, which is 4, the b value, which is 2m, and the c value, which is 1. Okay, so the discriminant is b squared, take 4ac. And what we want to know is, we want to know when the discriminant is less than 0. Okay, so what we're going to say is when the value of this is lower than 0. Okay, so I'm just going to pause it there for a sec. Whoops, not that one. Alright, yeah, I could see where I'm going to get tied up in knots in that, so I'm back here and I've just reread that quickly, and it says two distinct solutions. So less than 0, or the discriminant being less than 0, will have no solutions. Okay, so obviously that needs to change. AC is greater than 0. Okay, so now let's plug in our values. So we're squaring 2m, so that is 4m squared. Take 4 times the a value, which is 4, times the c value, and we want to know whether that's greater than 0. So we've got 4m squared, take 16, is greater than 0. Alright, now we're going to go 4m squared, take 4, is greater than 0. We can divide by 4 and divide by 4, which leaves us with m squared, take 4, greater than 0. Now we can either factorise this using dots, which is m take 2, m plus 2, greater than 0, or we can add 4 to both sides, take the square root, and the answer will be plus or minus 2. So what we need to do now, because we've got a quadratic inequality, we need to quickly sketch the graph. The two solutions are -2 and 2. It's an upright parabola because this is positive, so it's going to look like this. And we want to know when it's larger than 0, so this is when the y values are greater than 0. On the line is when y values are equal to 0, and below the line is when they're less than 0. So we're interested in these ones here, the ones above. So we say that m is an element of, and it's all the values of m up to -2, not including it. So from -infinity all the way to -2, union with all of these values after 2. So that's from 2 all the way to positive infinity. Okay, this one here also was not done particularly well. What impressed me was some students actually chose to sketch this first of all. So it's going to be 2 and 5, -3 and 10. So I can see that the quadratic is kind of going to look something like that. Okay, and what they want is the equation in this form. Okay, now that's something of a sort of a lot of students confused that and then started subbing in the points into this to try and get it in this form, but that means the end result just has to be in that form. Okay, but we can use whatever form of an equation that we want to actually get it into this form. And so the best form is going to be actually y equals a, x take b, x takes c, also known as the intercept form. Okay, because these are the x-intercepts, we can quickly whack them in. A equals x take 2, x take 5. Alright, now we need to know the dilation factor, so we're going to sub our third point in, or this point in. So we're going to go -10 equals a, and we're going to go -3 take 2 is -5, and -3 take 5 is -8. Alright, that is -10 equals 5/8 of 40, and a will be -10 over 40, or a equals -1/4. Okay, now what we're going to do is put this value into this. So we're going to say y equals -1/4 into x take 2, x take 5. Okay, now what we're going to do is expand this out because we need it in this form here. So I'm going to say that this is y equals -1/4 x squared take 2x take 5x plus 10 collect up like terms, and now I'm going to pass this through here. Alright, so that's probably the cleanest way I can write this. Okay, so of course this negative sign matches this. Okay, so we're looking good. Right, so state the coordinates of the turning point of the function. So those that sketch this realize that the turning point would actually be here, the midpoint between 2 and 5. And so they knew that the turning point would be 3.5 comma something. Okay, so what we needed to do then was put the 3.5 into this function here, and it'll throw out the y value when x is 3.5. So let's do that. It's a pretty tough substitution, as you can see. So I'm going to use the improper fraction of this. So I'm going to say that y equals, and I'm going to say negative, and I'm going to do, what am I going to do? -7 on 2 squared over 4 plus 7. Alright, so you can see here I'm second guessing this, okay, and this is a great example of where this method here I've worked out I'm going to get some really nasty fractions here, and I've thought, God, there's got to be a better way than this, and sure enough there is. So I'm going to actually get rid of that. And what am I going to do? Well, why am I substituting into this when I've got this nice looking thing here up above here with a lot of whole numbers here? So I'm actually going to sub it into this, which is actually just the same as this. So I'm going to say that this is -1/4, 7 on 2 take 2, and 7 on 2 take 5. So this is looking at a hell of a lot better than what it was. Okay, so this is -1/4, and we've got 7 on 2 take away 2, which is the same as 7 on 2 take away 4 over 2, so that is 3 on 2, and this is 7 on 2 take 10 on 2, which is negative 3 on 2. Alright, let's multiply this out. The answer is going to be positive, negative times a negative. 1 times 3 times 3 is 9, 4 times 2 times 2, 4 2s are 8, 8 2s are 16. The y value is 9 on 16. So our coordinates are 7 on 2, 9 on 16, and again, according to our graph, that's both in the positive or in quadrant 1, so that makes sense. So yeah, my apologies for that one, but it's a good example of seeing how I started to do the problem and then thought, oh my goodness, there's got to be an easier way of doing it. And of course, looking back on it, why was I subbing it into that when I've got this sitting here? Now, I'd have got the same result, but it would have taken me about another 10 minutes and I would have made about 10 mistakes on the fractions. So much easier to sub into this one. Alright, so nearly there. On to this problem here, and we've got a linear and a quadratic, and we want to know what the value of k is to produce no solutions, that is, no intersections. So remember, when we've got simultaneous equations, what we're going to do is actually let them just equal each other. So we've got x squared plus 4x plus 6 equals 3x take k. So now that they're equal to each other, if we solve this, we can work out where the solutions are. Okay, so what we're going to do is, to solve it, the left or the right hand side needs to equal 0. So I'm going to subtract 3x and add k. So I'm going to go x squared plus x plus 6 plus k equals 0. Alright, now I've got here do not have a solution. Okay, so the resulting function doesn't have a solution. Well, I know in this case what that has to mean is that the discriminant is less than 0. Do not have a solution means discriminant less than 0. So what we're going to do is run the discriminant on this. So our a value is 1, the b value is also 1, and the c value is 6 plus k. Alright, now what we're going to do is plug that into b squared take 4ac, and we want to know when this is less than 0. Alright, so our b value is 1, that's 1, take away 4, times the a value, which is 1, times the c value, which is 6 plus k, noting the brackets that I'm using there. Okay, now that's 1, take away 4, 6 plus k, less than 0, 1 take away 24, take away 4k, less than 0. This will be negative 23, take 4k, less than 0. Now we're going to add 23 to both sides, so that is negative 4k, less than 23. Just going to go over to here. We're going to go divide by negative 4 on both sides. K is greater than negative 23 on 4. Noting that we flipped the inequality when we divided by the negative. So that basically says for any value of k larger than negative 23 on 4, we're not going to get a solution. Okay? All the other values, if it's bang on, we're going to get one solution, and if it's less than that, we're going to get two solutions. Alright, so on to this question here. Sketch the graph of this, which again is this one here. Alright, so what do we know about this? Well, I know what the y-intercept is. It's 6. And now I need to get the turning point. Well, I can see quickly that it's not going to factorize, but you could try. You could try running the discriminant on that, and it will be less than 0. So in this case, what I'm going to do is I'm just going to find out the turning point using the rule x equals negative b on 2a. So here's my b value here, so it's x equals negative 4 over 2a, which is 2, x equals negative 2. So it is going to turn somewhere along this line here, Where? Well, if I sub in x equals -2 into that, I'll find the y value. So y equals, now -2 all squared is 2, take 4 times -2 is take 8 plus 6, y equals 0. That doesn't sound right. Okay, spotted my mistake because I knew it didn't turn. I know it can't be solved, so I knew it wouldn't turn on y equals 0, so I'm going to go back and undo this. And there was my mistake. If x is -2, -2 squared is 4. 4 take away 8 plus 6, and now this is looking better. 4 take 8 is -4 plus 6, y equals 2. Okay, so that's a relief, okay, because I was about to get a solution to this when I know there's no solutions. Alright, so here is our turning point. Here is our y-intercept. It doesn't have any x-intercepts, so we don't have to label them. And I know according to the axis of symmetry that it will go through there as well. So now let's draw the parabola. And label the key points. -2, 2, and 0. When x is 0, y is 6, 0, 6. Okay, the last one. By selecting appropriate value of k, sketch the graph of y equals 3x take k on the Cartesian plane above, such there's no unique solution. So that actually relates to what I found out here. Now, no unique solution is found by doing any value of k larger than -23 on 4. So the logical one is, well, what's a value of k larger than that? Well, 0. But I could try 1, 2, 3, 4. There's heaps of different answers here. -2, that would have been fine. But the easiest one to sketch would be one that runs through the origin. So I'm just going to say over here, let k equal 0, because that value there is going to produce no unique solution. So that means our equation is y equals 3x. Label the coordinates of any axial intercepts. So what it's going to do is run through the origin. The gradient is 3, so as x increases by 1, the y value is going to go up by 3. There's our second point there. Our graph runs through there. And you can pretty much see from that that they're never going to intersect. And that's it. So heaps of different solutions for this one. It had to be a k value that met the requirements of the previous question. So you would have got a variety of graphs of this one, and we marked it accordingly.